So, I recently had someone ask me about the uncertainty principle and what the rate wave function actually means. So, I decided to do a little video on just a qualitative example of what the uncertainty principle and the wave function means to me. So, the analogy I chose to use was, if you can imagine, you went to the store and you came home, and after a little while being home, you realize that you lost your wallet. So you don't know if your wallet's at home, you don't know if you left it at the store, you could have dropped it somewhere out here, although you're walking pretty fast, so maybe that's not as likely. And we can represent this idea with a wave function. So you were at home for a little while, but the more likely place that you lost it is at the store. So this has a higher probability, P, and X just represents the location of where the wallet might be. So because this probability has to be positive, we represent this as the square of some wave. So your wallet could be anywhere in here, but there's also the chance that someone might have picked it up. Maybe someone stole it, or maybe someone was trying to help you find it, or trying to deliver it to its owner rather. And because of this, you don't know if someone has it, and you don't know the position. So what happens if you find your wallet somewhere? So you have this wave function representing the probability of where your wallet is, and if you find it laying on the ground, let's say it's at the store, you immediately know the location, but now you don't know if someone picked it up or not. So if it was laying on the ground, you don't know if someone had it and then dropped it, or anything about where, if the wallet was moving before you found it at this spot. So that's all you know, is exactly this position. On the contrary, if someone picked it up, you know nothing about its location. So you know someone has it, you know it's moving, someone has it somewhere, but you have no idea where it might be. So this is the essence of the uncertainty principle and the collapse of the wave function. So in the first case, you know the position, but you don't know anything about where the wallet has been. So we can think about this as position and momentum. So the wallet is no longer moving because you picked it up, but we know its position exactly. And in this case, it's the opposite. We know it's moving, somebody has it somewhere, but we don't know anything about its position. So this is the collapse of the wave function, because psi squared no longer represents our system of interest.